November 3rd, 1943. Kummersdorf Proving Ground, 25 miles south of Berlin, Germany. Oberingenieur Friedrich Weber walked across the frozen testing range toward a wooden table where an American rifle lay waiting for examination. The Mauser Karabiner 98K he carried slung across his shoulder, the standard weapon of the Wehrmacht, felt suddenly heavier than usual. Weber was one of Germany's most experienced small arms engineers, a veteran of the Imperial Arsenal system who had spent 2 decades designing and evaluating infantry weapons. He had examined captured Soviet rifles, British Lee Enfields, and French MAS 36 seconds. He thought he understood the state of infantry small arms development across all combatant nations. He was about to discover he was wrong. The rifle on the table was a United States rifle, caliber .30, M1. American soldiers called it the Garand, after its designer, John Cantius Garand, a French-Canadian immigrant who had worked at Springfield Armory for more than 20 years. This particular specimen, serial number 405734, had been captured 3 weeks earlier in Italy near Salerno. A Wehrmacht infantry squad had overrun an American position during a counterattack on October 12th. They found this rifle lying beside its owner, a private from the 1st Infantry Division who had been killed by artillery fire. The rifle was undamaged, fully functional, and still loaded with ammunition. The weapon had been rushed through intelligence channels with unusual urgency. Field reports from Italy were describing American infantry fire rates that seemed impossible. German infantry officers reported being suppressed by what sounded like machine gun fire, only to discover it was coming from individual riflemen. Company commanders reported American squads maintaining sustained fire that German doctrine said was impossible without crew-served weapons. Battalion intelligence officers were filing reports that contradicted everything German military theory taught about infantry combat. Weber picked up the Garand and immediately felt the difference. It weighed 9.5 pounds unloaded, slightly less than his Kar 98K at 9 pounds. But the balance was entirely different. The centre of gravity sat further back, closer to the shooter's body. The wood stock was walnut, beautifully finished, with a pistol grip that felt natural in the hand. The barrel was 24 inches long, identical to the Kar 98K, but that was where the similarities ended completely. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber operated the rifle's action, pulling back the operating rod handle. The bolt moved smoothly, riding on carefully machined rails. He examined the mechanism with the practiced eye of an engineer who had spent his entire adult life studying how firearms worked. What he saw made him call over his assistant immediately. This was not a bolt-action rifle. This was something fundamentally different from anything in European military service. The M1 Garand was a semi-automatic rifle, gas-operated, using energy from fired cartridges to cycle the action automatically. When the shooter pulled the trigger and fired a round, expanding gases from the burning powder didn't just push the bullet down the barrel. Some of those gases were diverted through a port drilled through the barrel, approximately 6 inches from the muzzle. Those gases flowed into a gas cylinder and pushed against a piston. The piston drove the operating rod backward. The operating rod rotated and unlocked the bolt, extracted the spent cartridge case, ejected it, cocked the hammer, compressed the operating spring, then reversed direction under spring pressure. The spring drove the operating rod forward. The rod stripped a fresh cartridge from the magazine, chambered it, locked the bolt, and prepared the weapon to fire again. The entire cycle took approximately 0.1 seconds. The shooter never touched the bolt. The shooter simply kept the trigger pressed, aimed, and squeezed again. The rifle did everything else automatically. Weber had read intelligence summaries mentioning American semi-automatic rifles. The reports were vague, based on second-hand accounts and prisoner interrogations. He had assumed, as most German engineers had assumed, that the Americans were experimenting with semi-automatic designs in limited numbers, perhaps issuing them to specialized troops. Elite units, paratroopers, special assault companies. The idea that the United States had adopted a semi-automatic rifle as the standard infantry weapon for every rifleman in every unit seemed impossible. The technical challenges alone would be enormous. The manufacturing requirements would be staggering. The logistics of supplying ammunition to troops who could fire so much faster would be overwhelming. No nation had ever done it. No military had ever attempted to equip every common soldier with a semi-automatic rifle. Yet here it was, a standard-issue weapon, serial numbered in a sequence suggesting hundreds of thousands had already been manufactured. Weber examined the serial number again. 405734. If the numbering system started at 1, and if the Americans weren't using multiple numbering sequences, and if this rifle represented typical production, then the United States had already manufactured over 400,000 of these weapons. That would be enough to equip 40 infantry divisions. The implications were staggering. Weber opened the rifle's action fully and looked inside the receiver. The machining was extraordinary. The receiver was forged from a single billet of high-grade steel, then machined to tolerances that would be challenging even in German precision factories. Every surface that moved against another surface was polished smooth. The bolt lugs that locked the action were precisely cut and heat-treated for strength. The trigger mechanism was elegant, with a clean brake and positive reset. The safety was simple and intuitive, located where the thumb naturally rested. Everything about the weapon spoke of careful design and precision manufacturing, but what shocked Weber most was the magazine system. The M1 Garand didn't use a detachable box magazine like some experimental rifles he had evaluated. It used an en-bloc clip system. The shooter loaded 8 rounds at once, held in a thin steel clip. The entire clip, rounds and all, was inserted into the magazine from the top. When the last round was fired, the empty clip was automatically ejected upward with a distinctive ping sound, and the bolt locked open, signaling the weapon was empty. The shooter inserted a fresh clip, released the bolt, and was ready to fire again. The entire reload process took approximately 5 seconds for a trained rifleman. Weber counted the implications methodically, the way an engineer approached any problem. A German infantry rifleman with a Kar 98K carried his ammunition in stripper clips, each holding 5 rounds. To load his rifle, he opened the bolt, placed a stripper clip in the guide, pushed the rounds down into the internal magazine with his thumb, removed the empty clip, closed the bolt, and was ready to fire. The process took approximately 8 to 10 seconds for a trained soldier, longer under combat stress. The Kar 98K held 5 rounds in its internal magazine. After firing those 5 rounds, the rifleman had to reload, which meant another 8 to 10 seconds of downtime. An American rifleman with an M1 Garand loaded 8 rounds in approximately 3 seconds by inserting an en-bloc clip. He fired those 8 rounds as fast as he could aim and pull the trigger, approximately 1 round per second for aimed fire, faster for suppressive fire. When empty, the rifle ejected the clip automatically and locked open. The rifleman inserted a fresh clip in 2 seconds, released the bolt in 1 second, and was firing again. Total reload time, 3 seconds. The American could fire 8 rounds in the time it took a German to fire 5, then reload in 1/3 the time. The mathematics were brutal and undeniable. Weber walked to the firing line with the captured Garand and several loaded en-bloc clips. The ammunition was American, caliber .30, designated by the Americans as .3006 Springfield. The cartridge used a 150-grain bullet with a muzzle velocity of approximately 2,800 feet per second, similar to the German 7.92 by 57 mm Mauser cartridge. Ballistically, the 2 rounds were nearly identical, but the delivery system was completely different. He loaded the first en-bloc clip by pressing it down into the magazine. The follower clicked as it engaged. The bolt slammed forward automatically, chambering the first round with authority. He aimed at a target 100 meters distant, a standard man-sized silhouette. He squeezed the trigger smoothly. The rifle fired, with a sharp crack. The recoil was moderate, less than the Kar 98K despite similar ballistics. The rifle's gas operation absorbed some of the recoil energy. The semi-automatic action spread the recoil impulse over a longer time period, making it feel softer. He kept his sight picture, squeezed again. Another round fired. Again. He fired all 8 rounds in rapid succession, approximately 1 per second, maintaining reasonable accuracy on the target. The empty clip ejected with its characteristic ping. The bolt locked back. He loaded a fresh clip. 3 seconds. He was firing again. Weber fired 60 rounds in systematic testing. He evaluated accuracy at various ranges. He tested reliability by firing rapidly without pause. He examined how the weapon handled after heating from sustained fire. Garand performed flawlessly. Every round fed smoothly. Every case ejected cleanly. The accuracy was acceptable for infantry combat. Approximately 4-inch groups at 100 meters from a rest, adequate for hitting a man-sized target reliably at combat ranges out to 400 meters. The rifle showed no signs of malfunction, despite being fired rapidly enough to heat the barrel noticeably. Weber returned to the table and laid the Garand next to his K9 8K. He picked up the German rifle and went through the manual of arms he had practiced thousands of times. Open the bolt, insert a stripper clip, push 5 rounds down with his thumb, remove the clip, close the bolt, aim, fire. Work the bolt manually, extract the spent case, eject it, chamber a fresh round, lock the bolt. Aim, fire. Work the bolt again. Again. After 5 rounds, reload. Open the bolt. Insert clip. Push rounds. Remove the clip. Close bolt. The familiar rhythm of bolt action fire. Then he picked up the Garand again. Load clip. Fire. Load clip. Fire. The difference was overwhelming, not subtle, not marginal, not a modest improvement in an evolutionary development. This was revolutionary. This changed everything about infantry combat at the squad and platoon level. Weber called for his assistant, Hauptmann Klaus Richter, an infantry officer who had been seconded to the weapons testing program after being wounded at Stalingrad. Richter had extensive combat experience. He understood infantry tactics. Weber handed him both rifles and explained what he wanted. Richter would fire the K9 8K at a series of targets as fast as he could while maintaining combat accuracy. Weber would time him. Then Richter would fire the Garand at identical targets under identical conditions. They would compare results. Richter took the K9 8K first. 10 man-sized targets, arranged at ranges from 50 to 300 meters. Standard combat engagement distances. Weber gave the command. Richter began firing. He worked the bolt smoothly, efficiently, with the practiced movements of a veteran infantryman. Aim, fire, work the bolt. Acquire the next target, aim, fire, work the bolt. After 5 rounds, he reloaded quickly. He engaged all 10 targets, firing 1 carefully aimed shot at each. Weber checked his stopwatch. 43 seconds. Richter had hit 9 of the 10 targets, missing only the most distant one at 300 meters. Now the Garand. Same targets. Reset. Same ammunition, identical cartridge performance, same shooter, same skill level, same experience. Weber gave the command. Richter began firing. The sound was different immediately. Crack, 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 crack. Steady, rhythmic, without the pause for bolt manipulation between shots. Richter engaged each target, fired, moved smoothly to the next. No bolt to work. No manual extraction. The rifle did everything automatically. After 8 rounds, he reloaded quickly, the clip inserted smoothly. He continued firing. Weber watched the stopwatch. 22 seconds. Richter had hit all 10 targets. The semi-automatic action allowed him to maintain his sight picture and firing, and rhythm without the disruption of manual bolt operation. The numbers were stark. Same shooter, same targets, same conditions. The Garand was nearly twice as fast while actually improving accuracy because the shooter never lost his sight picture between shots. Richter set both rifles down and looked at Weber. The engineer saw recognition in the infantry officer's eyes. Richter understood immediately what this meant in tactical terms. A German infantry squad, the Grundtrupp, consisted of 10 men built around the MG-34 or MG-42 machine gun. The machine gun and its crew of 3 men provided the squad's primary firepower. The other 7 men, armed with Kar 98K rifles, supported the machine gun, provided local security, and engaged targets the machine gun couldn't address. German infantry doctrine, developed over decades and proven in 2 world wars, centered on the machine gun. The riflemen existed to support and protect the machine gun. The machine gun provided suppressive fire and offensive firepower. An American infantry squad, according to captured documents Weber had reviewed, consisted of 12 men divided into a rifle section and a Browning automatic rifle section. But unlike German doctrine, where riflemen were secondary to the machine gun, American doctrine treated every rifleman as a significant source of firepower. With M1 Garands, those riflemen could put out sustained fire that approached the volume of the BAR in short bursts. A 12-man American squad with 11 M1 Garands and 1 BAR could generate sustained fire that exceeded a German squad in total rounds fired per minute. Weber did the mathematics carefully, writing the calculations in his field notebook. A German rifleman with a Kar 98K could fire approximately 15 well-aimed shots per minute under combat conditions. That accounted for aiming time, trigger press, bolt manipulation, and reloading. 15 rounds per minute was a realistic sustained rate for trained infantry. 7. German riflemen could collectively fire approximately 105 rounds per minute, plus approximately 200 rounds per minute from the MG-42, for a total of just over 300 rounds per minute of squad firepower. An American rifleman with an M1 Garand could fire approximately 30 well-aimed shots per minute under identical conditions. The semi-automatic action eliminated bolt manipulation time. Reloading was faster. The shooter maintained his sight picture. 30 rounds per minute was achievable and sustainable. 11 American riflemen could collectively fire approximately 330 rounds per minute, plus approximately 300 to 500 rounds per minute from the BAR, depending on rate of fire selected. Total squad firepower, between 600 and 800 rounds per minute, more than double the German squad's output. But the raw volume wasn't the complete story. Weber understood that firepower effectiveness wasn't just about rounds fired. It was about rounds on target, about sustained suppression, about the psychological impact on the enemy. The M1 Garand changed the fundamental equation of infantry combat. German infantry tactics, refined through experience in 2 world wars, relied on fire and movement with the machine gun as the base of fire. The machine gun pinned the enemy while rifle squads maneuvered. The riflemen protected the machine gun and eliminated point targets. If the machine gun was knocked out, suppressed, or ran out of ammunition, the squad's offensive capability dropped dramatically. The riflemen couldn't generate enough fire to suppress an enemy position effectively. American infantry tactics, as Weber was beginning to understand them from captured field manuals and prisoner interrogations, distributed firepower more evenly across the squad. Every rifleman was a significant threat. Knocking out the BAR reduced the squad's firepower, but didn't cripple it. The M1-equipped rifleman could still generate substantial suppressive fire. An American squad was more resilient, harder to suppress, and more dangerous at every level. The strategic implications began crystallizing in Weber's mind as he examined the captured rifle throughout the afternoon. The United States had committed to mass-producing a complex semi-automatic rifle and issuing it to every common infantry soldier. This wasn't a limited program. This wasn't experimental. According to intelligence estimates, the Americans were already producing the M1 Garand at rates exceeding 4,000 rifles per day. Springfield Armory and Winchester Repeating Arms were running production lines continuously. The rifles were flowing to training camps, replacement depots, and overseas theatres in enormous quantities. Germany, meanwhile, was still equipping its infantry with essentially the same bolt-action rifle design that had served in World War I. The Kar-98K was an excellent rifle. Accurate, reliable, robust. German soldiers trusted it completely. But it was fundamentally a 19th-century design, a manually operated repeating rifle that would have been familiar to a soldier from 1890. The Mauser action was perfected, optimized, refined to the highest degree possible. But it was still manual. The soldier still worked the bolt by hand for every shot. Germany had experimented with semi-automatic rifles. The Gewehr 41 program had produced working prototypes, but the weapons were temperamental, heavy, and difficult to manufacture. The Gewehr 43, an improved design, was entering limited production, but would never be issued in large numbers. Germany would fight the rest of the war primarily with bolt-action rifles, while facing an enemy where every infantryman carried a semi-automatic. Weber picked up the Garand again and looked at it with new understanding. This weapon represented more than just clever engineering or innovative design. It represented industrial capacity on a scale Germany couldn't match. The M1 Garand required precision machining, specialized tooling, and quality control that demanded enormous factory resources. The receiver alone required multiple operations on expensive machine tools. The barrel needed precise rifling and careful heat treatment. The gas system needed exact tolerances to function reliably. Springfield Armory had been manufacturing rifles since 1794. The facility had generations of institutional knowledge about weapons production. Winchester Repeating Arms had been producing firearms since 1866. Both facilities had access to steel mills, tool manufacturers, skilled labor, and electrical power in quantities that German industry, after 4 years of war and strategic bombing, could no longer reliably provide. The United States was producing rifles faster than Germany could produce trained infantrymen to carry them. American factories were turning out M1 Garands at rates that would have equipped the entire Wehrmacht infantry in less than 2 years. And this was just one weapon system among dozens where American production exceeded German capacity by factors of 2, 5, or 10 to 1. Weber spent the rest of that November afternoon in 1943 firing the captured Garand, examining its mechanism, and writing detailed notes. He tested its reliability under various conditions. He examined how it performed when dirty, when cold, when hot from sustained fire. He evaluated its accuracy at extended ranges. He assessed its durability and resistance to damage. In every test, the rifle performed admirably. It was clearly a mature design, well past the experimental phase, ready for mass issue to troops. His report would be comprehensive, technical, and honest. He would document Garand's capabilities precisely. He would explain the tactical implications clearly. He would note that American infantry armed with this weapon had a significant advantage in firepower over German infantry at the squad and platoon level. He would recommend immediate acceleration of German semi-automatic rifle programs to restore parity. But Weber already knew what would happen to his report. It would move up through channels, from Kummersdorf to the Army Weapons Office in Berlin, from there to the High Command. It would be read by officers who would understand the implications. And then it would be filed away, because Germany, in late 1943, lacked the industrial capacity, the raw materials, and the time to respond effectively. The window for developing and fielding a comparable weapon had closed. The decisions that mattered had been made years earlier, before the war, when doctrine was set and production priorities were established. The journey to this moment of realization had begun decades earlier, in the years between the world wars, when military theorists debated the future of infantry combat and when designers sketched mechanisms that could fire automatically. The M1 Garand wasn't created in a vacuum. It was the result of specific choices, specific investments, and specific beliefs about what infantry combat would require. John Cantius Garand was born in 1888 in Saint-Rémy, Quebec, Canada. His family moved to Connecticut when he was 11 years old. He left school early to work in textile mills, then found employment in machine shops, where his natural mechanical aptitude became apparent. He taught himself engineering, studying at night, learning by doing. By 1917, when the United States entered World War I, Garand was working as a designer for the Bureau of Standards in Washington. The war demonstrated that infantry firepower was decisive in modern combat. Machine guns dominated the battlefield. Riflemen, armed with bolt-action rifles, couldn't generate enough fire to suppress machine gun positions or break through defensive lines. Military theorists recognized that increasing the individual rifleman's firepower would multiply infantry effectiveness. Semi-automatic rifles, weapons that fired one round per trigger pull without manual reloading, seemed like the obvious solution. Several nations experimented with semi-automatic rifle designs in the 1920s and 30s. France developed the Meunier rifle, issued in limited numbers. Mexico adopted the Mondragon rifle, though with mixed results. The Soviet Union fielded the Tokarev rifles, the SVT-38 and SVT-40, in significant numbers. But every nation faced the same fundamental challenges. Semi-automatic actions were complex. They required precision manufacturing. They were sensitive to variations in ammunition. They were heavier than bolt-action rifles. They were more expensive to produce. Most importantly, they required reliable ammunition with consistent powder charges, bullet weights, and pressure curves. The United States Army began seriously exploring semi-automatic rifles in the early 1920s. The Army wanted a weapon that was reliable, accurate, durable enough for combat, and simple enough for conscript soldiers to maintain. In 1929, John Garand, now working at Springfield Armory, submitted his design for a gas-operated, semi-automatic rifle chambered for the standard .3006 Springfield cartridge. His design used gas tapped from the barrel to drive a piston that cycled the action. The bolt locked with rotating lugs, similar to bolt-action designs but operated automatically. The weapon used an on-block clip holding 8 rounds. The Army tested Garand's design extensively throughout the early 1930s, comparing it against dozens of competing designs from other inventors and major firearms manufacturers. Pedersen, Browning, Thompson, and others submitted rifles. Each design was evaluated for accuracy, reliability, ease of manufacture, maintainability, and durability. Garand's design consistently performed well. It was reliable. It was accurate. It was relatively simple to manufacture compared to some competitor designs. It used the standard military cartridge without requiring new ammunition production infrastructure. On January 9, 1936, the United States Army officially adopted Garand's rifle as the United States Rifle, caliber .30, M1. The decision was revolutionary. No other major military had adopted a semi-automatic rifle as its standard infantry weapon. The Army committed to replacing every Springfield Model 1903 bolt-action rifle, every M1000, 917 Enfield, every rifle in the infantry with the new M1 Garand. It was an enormous commitment, requiring retooling factories, training armourers, writing new field manuals, and developing new infantry tactics. Springfield Armory began production in 1937. The first rifles went to infantry units for field testing. Problems emerged immediately. The gas system needed refinement. The trigger group required modification. The stock dimensions needed adjustment. Garand and the Springfield Armory engineers addressed each issue systematically, modifying the design based on feedback from soldiers. By 1940, the M1 Garand had evolved into a mature, reliable weapon ready for mass production. When Germany invaded Poland in September 1939, initiating World War II in Europe, the United States had approximately 80,000 M1 Garands in service, enough to equip perhaps 8 infantry divisions. Production was ramping up, but slowly. The American military, isolated from the war by 2 oceans, was small. There was no urgency. That changed on December 7, 1941, when Japan attacked Pearl Harbor. Suddenly, the United States needed millions of soldiers and the weapons to arm them. Springfield Armory expanded production dramatically. Winchester Repeating Arms was contracted to build a second production line. The factories operated 3 shifts, 24 hours per day, 7 days per week. Workers who had been producing sporting rifles and shotguns were retrained to build military weapons. Women entered the workforce in large numbers, taking jobs traditionally held by men who were now in uniform. The production rate climbed from hundreds of rifles per day to thousands. By November 1943, when Weber examined the captured specimen at Kummersdorf, American factories had produced over 2 million M1 Garands. The rifles were being issued to infantry replacements immediately upon completion of basic training. They were being shipped overseas to units in England, preparing for the invasion of Europe, to units in Italy, pushing up the peninsula, to units in the Pacific, island hopping toward Japan. The United States was in the process of fielding an entirely semi-automatic equipped infantry force, something no nation had ever attempted. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps. Let us continue producing in-depth content like this. The contrast with German rifle development was stark and revealing. Germany entered World War II with the Kar 98K as its standard infantry rifle. The weapon was a shortened version of the Gewehr 98, the rifle that had armed German infantry in World War I. The Mauser action was superb, arguably the finest bolt-action design ever created. The rifle was accurate, reliable, and robust. German soldiers could maintain it under terrible conditions. It functioned in Arctic cold, desert heat, and Russian mud, but it was still a bolt-action rifle requiring manual operation for each shot. German designers recognized the advantages of semi-automatic fire. In the 1930s, the Army Weapons Office had initiated programs to develop self-loading rifles. The Gewehr 41M and Gewehr 41W programs produced working rifles, but both designs had significant problems. They were heavy, weighing over 11 pounds. They were complex, with intricate mechanisms that required careful maintenance. They were gas-operated systems that used unconventional designs. German soldiers found difficult to understand and maintain. Most critically, they were sensitive to ammunition variations and environmental conditions. Reliability issues plagued both weapons. By 1943, German engineers had developed the Gewehr 43, an improved design that addressed many of the Gewehr 41's problems. The G43 used a more conventional gas system similar to the Soviet Tokarev rifles captured on the Eastern Front. It was more reliable than its predecessors. It used a detachable box magazine holding 10 rounds. It was reasonably accurate, but production numbers remained limited. Germany would produce approximately 400,000 G43 rifles during the entire war, a fraction of the number needed to equip every infantryman. The reasons for limited production were complex and revealing. German industry was strained by competing priorities. Tanks, aircraft, submarines, and artillery absorbed enormous resources. Small arms were relatively low priority. The Kar 98K, while manually operated, was cheap to produce, simple to maintain, and adequate for most combat situations. Transitioning to semi-automatic rifles would require retooling factories, training armourers, and accepting higher per-unit costs. With Germany fighting on multiple fronts, with strategic materials in short supply, with factories under aerial bombardment, with transportation systems disrupted, the Wehrmacht chose to continue with proven bolt-action rifles rather than commit to a massive semi-automatic conversion. There was also a doctrinal element to the decision. German infantry tactics centered on the machine gun. The MG-34 and later the MG-42 provided enormous firepower, firing at rates exceeding 1,000 rounds per minute. German doctrine treated riflemen as supporting elements for the machine gun. Increasing individual rifleman firepower was less important than protecting and supplying the machine gun. Semi-automatic rifles for riflemen seemed less critical when the machine gun provided primary suppression. American doctrine evolved differently. The United States Army studied World War I lessons and concluded that distributing firepower across the squad, rather than concentrating it in crew-served weapons, made infantry more flexible and resilient. American theorists believed that every soldier should be a significant source of firepower. The Browning automatic rifle provided mobile automatic fire, but the individual rifleman's capability mattered enormously. Semi-automatic rifles fit this doctrinal approach perfectly. The doctrinal differences reflected deeper philosophical differences about infantry combat. German doctrine, influenced by decades of Prussian military tradition, emphasized combined arms integration and mission-type tactics. Junior leaders received objectives and were expected to accomplish them using their judgment. The machine gun was the killing weapon. Riflemen maneuvered to support it. This approach worked brilliantly when German forces had numerical superiority, adequate supplies, and high-quality soldiers. But as the war progressed and these advantages eroded, the system's weaknesses became apparent. American doctrine, still evolving as the United States built a mass army from a small peacetime force, emphasized firepower and logistics. American planners assumed that conscript soldiers with limited training would need simple, clear tactics and overwhelming material support. Rather than expecting brilliance from junior leaders, American doctrine provided abundant firepower at every level. Every rifleman was dangerous. Every squad could generate significant fire. Every platoon had access to supporting weapons. The approach accepted higher ammunition consumption in exchange for reduced tactical complexity and increased soldier survivability. The M1 Garand fit perfectly into this framework. It multiplied individual firepower without requiring additional training in complex tactics. A soldier who could operate a bolt-action rifle could operate the Garand with minimal additional instruction. The manual of arms was straightforward. Load the clip, aim, fire. The rifle did the rest. There were no complicated fire control procedures, no intricate maintenance rituals, no esoteric knowledge required. The weapon was soldier-proof in the best sense of the term. Weber's report from Kummersdorf reached the Army Weapons Office in Berlin within a week. The document was comprehensive, running to 37 pages with detailed technical drawings, performance data, and tactical analysis. Weber documented every aspect of the Garand's design and performance. He noted its strengths honestly: reliability, ease of use, manufacturing quality, and overwhelming firepower advantage. He noted its weaknesses fairly. The en-bloc clip system made topping off the magazine difficult. The block-timed fire rate rifle was slightly heavier than necessary. The gas system required cleaning after extended firing. But the conclusion was unavoidable. The M1 Garand gave American infantry a decisive firepower advantage at the squad and platoon level. German infantrymen armed with K9 8K rifles were outgunned in direct engagements. The report recommended immediate acceleration of G43 production to restore parity, development of improved semi-automatic designs for future use, and tactical adjustments to minimize exposure to American rifle fire. The report was filed, distributed to relevant departments, and effectively ignored. By November 1943, Germany was fighting desperately on multiple fronts. The Eastern Front consumed men and material at catastrophic rates. Italy had surrendered, and Allied forces were advancing up the peninsula. Strategic bombing was destroying industrial capacity. The Battle of the Atlantic was turning against German U-boats. Resources that might have been allocated to small arms development were desperately needed elsewhere. The Wehrmacht would fight the rest of the war primarily with K9 8K rifles, while facing enemies with semi-automatic weapons. But the soldiers in the field, the infantrymen actually facing American troops, learned the lessons that Berlin chose to ignore. The first significant engagements between German forces and M1-equipped American infantry occurred in North Africa in late 1942 and early 1943. German soldiers reported being surprised by the volume and intensity of American rifle fire. Initial reports attributed it to American doctrine emphasizing fire over maneuver, wasting ammunition through indisciplined shooting. German officers initially believed American troops were poorly trained, firing wildly without aimed shots. This assessment changed rapidly as German forces encountered American infantry in Italy. During the Salerno landings in September 1943, German defenders counterattacking American positions discovered that American rifle fire was neither indisciplined nor wasted. It was devastatingly effective. American infantrymen engaged German soldiers at ranges from 50 to 400 meters with sustained, but accurate fire that suppressed German maneuver and inflicted casualties at rates that seemed impossible for rifle-armed troops. A German infantry officer, Hauptmann Heinrich Müller, commanding a company of the 16th Panzer Division near Salerno, described the experience in his after-action report. His company had been ordered to counterattack American positions that had penetrated German lines near Battipaglia. The company advanced in standard fashion, using terrain for cover, moving by squads, while the machine gun sections provided supporting fire. As they closed to within 200 meters of American positions, rifle fire erupted with intensity Müller had not experienced in 2 years of combat in Russia. The fire wasn't the sporadic crack of bolt-action rifles fired by individual soldiers taking careful aimed shots. It was a continuous roar, overlapping shots blending into sustained fire that resembled machine gun fire but came from individual fighting positions. Müller's lead squad went to ground immediately, pinned by fire they couldn't suppress with their own rifles. The machine gun section attempted to establish a firing position, but incoming American fire was so intense that the gun couldn't be set up properly. Within minutes, 3 of Müller's men were wounded, including one of his squad leaders. The attack stalled, then collapsed as American fire intensified. Müller withdrew his company, having accomplished nothing except confirming that American rifle fire was extraordinarily dangerous. In his report, he noted that American soldiers appeared to fire their rifles as rapidly as his men fired submachine guns, but with rifle accuracy at rifle ranges. He recommended treating American rifle squads as if they were equipped with light machine guns, using appropriate caution and supporting fires before closing to assault distance. Similar reports came from units across Italy throughout late 1943 and into 1944. German infantry learned, through painful experience, that closing with American infantry required more supporting fire, more careful use of terrain, and more caution than engagements with British or Soviet forces. The Americans simply put out more rifle fire, more accurately, more sustainably than enemies equipped with bolt-action weapons. The invasion of France on June 6, 1944, brought hundreds of thousands of M1 equipped American soldiers into contact with German forces in northwest Europe. The firepower differential became even more apparent in the hedgerow fighting of Normandy. The bocage terrain of small fields, separated by thick hedgerows, created close-range combat conditions ideal for demonstrating the Garand's advantages. Engagements occurred at ranges from 50 to 200 meters, distances where semi-automatic fire was devastatingly effective. German soldiers defending hedgerow positions found themselves outgunned by American infantry assaulting across open fields. A German squad armed with Kar 98K rifles could fire perhaps 70 to 80 well-aimed shots per minute collectively. An American squad with M1 Garands could fire over 300 rounds per minute collectively. The Germans had machine guns, certainly, but American infantry tactics emphasized suppressing German machine gun positions with concentrated rifle fire, then maneuvering to eliminate them with grenades or flanking attacks. The mathematics of ammunition consumption told the story clearly. German soldiers were trained to conserve ammunition, firing only when they had clear targets, making each shot count. This was partly tactical doctrine, partly necessity. German logistics were strained. Ammunition resupply was irregular. Soldiers learned to make their ammunition last. A German rifleman typically carried 60 rounds, 12 5-round stripper clips, in his basic load. In sustained combat, he might fire all 60 rounds in an hour of fighting. Resupply would come from unit stocks carried by horse-drawn wagons or trucks, assuming roads were open and logistics were functioning. American soldiers were trained to use ammunition freely, suppressing enemy positions and dominating the battlefield with firepower. This was tactical doctrine supported by overwhelming logistics. An American rifleman carried 80 rounds in en bloc clips as his basic load, plus additional bandoliers if available. He could easily fire 100 or more rounds in an hour of combat. Resupply came from enormous stocks transported by thousands of trucks moving on secure roads. American ammunition expenditure rates would have been logistically impossible for German forces to sustain. A statistical analysis conducted by the United States Army's Operations Research Office after the war examined ammunition consumption rates in Northwest Europe from June through December 1944. American infantry units averaged approximately 120 rounds per rifleman per day of combat. German units, facing ammunition constraints and equipped with bolt-action rifles, averaged approximately 40 rounds per rifleman per day of combat. American infantry fired 3 times as much rifle ammunition as German infantry, and each round was delivered faster, more accurately, and with less physical effort from the shooter. The Garand's semi-automatic action didn't just increase rate of fire, it improved accuracy under combat conditions. When a soldier fires a bolt-action rifle, he must remove his hand from the trigger, grasp the bolt handle, lift the bolt, pull it back, push it forward, rotate it down, then return his hand to the trigger and reacquire his sight picture. This process disrupts the aim. Even practiced shooters lose their precise sight alignment during bolt manipulation. Under combat stress, with adrenaline affecting fine motor control, with the shooter tired and possibly wounded, bolt manipulation becomes slower and less smooth. Sight picture suffers. Accuracy degrades. When a soldier fires the M1 Garand, he keeps both hands on the weapon throughout the firing sequence. His right hand remains on the pistol grip with his finger on the trigger. His left hand remains on the forend, supporting the rifle. His sight picture barely changes between shots. The recoil moves the rifle, but the shooter controls it and returns to aim naturally. The next shot is ready immediately. The shooter maintains his firing rhythm and concentration without the disruption of manual bolt operation. Under combat conditions, this translates to faster aimed fire and better practical accuracy. American soldiers who trained with both the Springfield M1903 bolt-action rifle, the M1 Garand almost universally preferred the Garand. Corporal James Henderson, who served with the 1st Infantry Division in North Africa and Italy, described the transition in his memoir written after the war. His unit had initially been equipped with M1903 Springfields when they deployed to England in 1942. They received M1 Garands in the early 1943 before the invasion of North Africa. Henderson had qualified as expert with the Springfield and was initially skeptical about changing to a new weapon. He was familiar with the Springfield, trusted it, and shot it well. The Garand seemed heavier, more complex, potentially less reliable. His skepticism vanished during his first combat engagement near Kasserine Pass in February 1943. His squad encountered a German patrol at approximately 150 meters range. Both sides went to ground and began exchanging fire. Henderson fired his Garand as fast as he could acquire targets, approximately 1 round every 2 seconds. He emptied his 8-round clip in 16 seconds, loaded a fresh clip, and continued firing. His squad leader, armed with a Springfield, fired more slowly, working the bolt between shots, reloading after 5 rounds. The difference in fire volume was dramatic. Henderson estimated his squad, with 9 men armed with Garands, fired over 60 rounds in the first minute of the engagement. A similar squad armed with Springfields might have fired 30 rounds in the same period. The German patrol withdrew under the intense fire. Henderson's squad suffered no casualties. He became a convinced advocate of the Garand, later writing that he would never willingly trade it for any bolt-action rifle regardless of reputation. The semi-automatic action, he wrote, made him feel like he had the advantage in every engagement. He could shoot faster, reload faster, and keep pressure on the enemy continuously. The Garand made him confident, even aggressive, in ways the Springfield never had. Thousands of American soldiers had similar experiences. The M1 Garand became one of the most beloved weapons in American military history, praised by soldiers who carried it and trusted their lives to it. General George S. Patton famously called it the greatest battle implement ever devised, a quote that became legendary among soldiers and firearms enthusiasts. While Patton's assessment was hyperbolic, reflecting his dramatic personality, it captured how soldiers felt about the weapon. It worked. It worked reliably, consistently, under terrible conditions. It gave them an edge. German soldiers facing M1-equipped American infantry developed a grudging respect for the weapon, even as they cursed its effectiveness. Interviews conducted with German prisoners of war throughout 1944 and 45 reveal consistent patterns. German soldiers recognized that American infantry rifle fire was significantly heavier and more sustained than their own. Many prisoners mentioned the distinctive sound of Garand fire, the rapid crack, 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 crack that signaled American infantry positions. Some mentioned the metallic ping of the ejecting on-block clip, claiming they listened for that sound to identify when American soldiers were reloading. Whether this was actually tactically significant is debatable. In combat conditions, with multiple soldiers firing, explosions, machine guns, and general chaos, hearing individual clip ejections was unlikely. But the fact that German soldiers discussed it indicates they were very aware of the Garand's capabilities and looking for any exploitable weakness. The Garand did have weaknesses, though none were tactically decisive. The N-block clip system, while fast for loading a completely empty rifle, made it difficult to top off a partially full magazine. If a soldier fired 4 rounds from his 8-round clip, he couldn't easily add 4 more rounds. He had to fire the remaining 4 rounds or manually eject the partial clip, wasting unfired ammunition. In extended engagements with lulls in firing, soldiers sometimes found themselves with partially full magazines and no good way to reload without wasting ammunition. The rifle was sensitive to maintenance. The gas system accumulated carbon residue from burning powder. After several hundred rounds, the gas port could become restricted, causing malfunctions. The operating rod and its channel needed lubrication. The bolt needed cleaning. Under combat conditions, with limited time and resources for maintenance, rifles sometimes became less reliable. Soldiers learned to clean their Garands whenever possible, using whatever lubricants were available. The rifle was relatively heavy at 9.5 pounds unloaded. With a full 8-round clip and sling, it weighed over 10 pounds. Soldiers carrying the weapon for miles, climbing mountains, or moving through dense terrain felt every ounce. The weight was necessary for durability and to manage recoil, but it was still fatiguing over long marches. The semi-automatic action required quality ammunition with consistent powder charges and bullet weights. Variations in ammunition could cause malfunctions. The United States ammunition industry, with its high-quality control standards and enormous production capacity, provided excellent ammunition consistently, but captured German or other foreign ammunition sometimes caused reliability problems when American soldiers tried to use it. Despite these limitations, the M1 Garand was an extraordinarily successful weapon. Its advantages overwhelmingly outweighed its disadvantages in combat conditions. American infantry armed with Garands had decisive firepower superiority over enemies with bolt-action rifles. This advantage translated directly into combat effectiveness, casualty ratios, and ultimately into victory. The industrial story behind the Garand was as significant as the tactical story. Producing the M1 Garand in the quantities required to equip millions of soldiers was an enormous manufacturing challenge. The rifle was complex compared to bolt-action weapons. The receiver required multiple machining operations on sophisticated machine tools. The barrel needed precise rifling and careful heat treatment. The gas system components needed exact tolerances. The operating rod had to be manufactured to precise specifications. The trigger group required careful assembly. Every part had to meet quality standards, or the rifle wouldn't function reliably. Springfield Armory, the primary production facility, was a government-owned arsenal that had been manufacturing military firearms since 1794. The facility occupied several hundred acres in Springfield, Massachusetts, with dozens of buildings housing machine shops, assembly lines, testing ranges, and administrative offices. At peak production during World War II, Springfield employed over 13,000 workers, operating 3 shifts, and continuously. The production process began with raw steel billets delivered by rail from steel mills in Pennsylvania and Indiana. The billets were heated in furnaces until cherry red. then placed in massive forging presses that shaped them into rough receiver forgings. The forgings were allowed to cool, then went through initial machining to establish reference surfaces. From there, they moved through a series of machining operations, each performed on specialized equipment by trained operators. The receiver required approximately 47 separate machining operations to reach final dimensions. Each operation removed metal precisely, creating the complex internal geometries necessary for the rifle to function. Milling machines cut the bolt raceway. Boring machines created the barrel threads. Broaching machines cut the magazine well and trigger group cavity. Every operation was followed by inspection. Dimensions were verified with precision gauges. Surfaces were examined for defects. Receivers that failed inspection were scrapped or sent back for rework. Barrels started as solid steel bars, approximately 30 inches long. The bars were drilled through their length to create the initial bore. Then they were reamed to precise diameter. The rifling was cut using a button rifling process that pushed a hardened steel tool through the bore, creating the spiral grooves that would spin the bullet for accuracy. After rifling, the barrel was heated to specific temperatures and then quenched in oil to achieve the correct hardness. Finally, the barrel was threaded, chambered, and test-fired to verify accuracy and function. Other components went through similar processes. The operating rod was forged, machined, and heat-treated. The bolt was machined from bar stock, with its locking lugs carefully cut and hardened. The trigger group components were manufactured to close tolerances and assembled by skilled workers. The stock was carved from walnut, blanks, shaped to fit the receiver and barrel, then finished with oil. Final assembly brought all components together. The barrel was screwed into the receiver and tightened to precise torque specifications. The gas cylinder assembly was installed, the operating rod and bolt were fitted. The trigger group was installed and adjusted. The stock was attached. The rifle was test-fired to verify function and accuracy. Rifles that passed testing were marked with serial numbers, proofed, and sent to packing facilities for shipment to depots. The entire process, from raw steel to finished rifle, took approximately 3 weeks of elapsed time, though much of that was waiting between operations. Actual machining and assembly time was measured in hours. At peak efficiency, Springfield Armory produced approximately 1,000 rifles per day. Winchester Repeating Arms, using similar processes in their New Haven, Connecticut facility, produced an additional 500 to 700 rifles daily. The scale of production was staggering by any historical standard. From January 1941 through August 1945, American factories produced approximately 4,800,000 M1 Garand rifles. That was enough to equip every infantryman in the entire United States Army multiple times over, with sufficient surplus to supply training bases, replacement depots, and war stocks. The rifles went everywhere. American forces fought Europe, North Africa, the Pacific, China, Burma, India Theater, Alaska, and garrisons worldwide. German industry, by comparison, never approached these production numbers for any semi-automatic rifle. Total G43 production from 1943 to 1945 was approximately 400,000 rifles, less than 10% of American M1 Garand production. German factories simply lacked the capacity, the tooling, the skilled labor, and the uninterrupted electrical power necessary for mass production of complex weapons. Strategic bombing disrupted production continuously. Raw material shortages forced compromises in quality. Labor shortages, as men were drafted for military service, reduced skilled worker availability. The Kar-98K, being simpler to manufacture, continued as Germany's primary infantry rifle throughout the war. German factories produced approximately 14 million Kar-98K rifles from 1935 through 1945. That sounds impressive compared to total American rifle production, which exceeded 17 million rifles of all types, including over 10 million M1 Garands and M1 carbines combined. The United States, with its vast industrial capacity and secure production facilities, simply outproduced Germany by overwhelming margins. The logistics of supporting M1-equipped infantry were equally impressive. Each Garand required approximately 120 rounds of ammunition per day of combat, as noted earlier. Multiply that by hundreds of posset, thousands of riflemen, and the numbers become astronomical. American infantry in Europe from D-Day through VE Day fired approximately 4 billion rounds of .3006 ammunition. That's 4,000 million individual cartridges, each manufactured to precise specifications, packaged, shipped across the Atlantic, distributed to depots, trucked to forward units, and issued to soldiers. The ammunition production infrastructure supporting the M1 Garand was itself a marvel of industrial organization. Major manufacturers included Lake City Army Ammunition Plant in Missouri, Frankfurt Arsenal in Pennsylvania, Denver Ordnance Plant in Colorado, Twin Cities Arsenal in Minnesota, and numerous commercial manufacturers contracted for war production. These facilities operated continuously, 24 hours per day, 7 days per week. They employed hundreds of thousands of workers, many of them women who had never worked in manufacturing before the war. The production process for a single cartridge involved dozens of steps. Brass cases were drawn from sheet brass, formed in progressive dies, annealed, and trimmed to length. Primers were manufactured separately, loaded with a sensitive primer compound, and inserted into case heads. Powder was manufactured at dedicated facilities, carefully formulated to provide consistent performance. Bullets were manufactured from lead cores with copper jackets, swaged to precise dimensions. Final assembly brought all components together: case, primer, powder, and bullet, each loaded to exact specifications to ensure reliable function in the M1 Garand's gas system. Quality control was rigorous. Samples from each production lot were proof-tested at special facilities. Cartridges were fired in pressure barrels to verify they met specifications for chamber pressure, velocity, and accuracy. Batches that failed testing were rejected. The entire system, from raw materials to finished ammunition in soldiers' hands, represented industrial coordination on an unprecedented scale. German ammunition production, while substantial, operated under significantly greater constraints. Strategic bombing targeted ammunition plants. Raw material shortages, particularly copper for cartridge cases, forced Germany to use substitute materials like steel cases with thin brass wash. Quality control suffered as production was dispersed to smaller facilities to reduce bombing vulnerability. German ammunition by late 1944 was noticeably less consistent than earlier production, with variations that would have caused reliability problems in sensitive semi-automatic weapons like the M1 Garand. The cumulative effect of American industrial superiority in rifles, ammunition, and logistics was devastating to German forces. American infantry could sustain combat intensity that German forces couldn't match. When ammunition ran low, American units called for resupply, and trucks arrived within hours. When German units ran low on ammunition, resupply was uncertain, often delayed by disrupted transportation and limited stocks. The Battle of the Bulge in December 1944 and January 1945 demonstrated the cumulative advantages American infantry possessed. German forces launched a massive surprise offensive through the Ardennes, initially achieving significant success against American units. But as the battle developed and American forces recovered from initial shock, the fundamental advantages of superior equipment and logistics became decisive. American infantry, armed with M1 Garands, generated sustained fire that German forces couldn't suppress. American ammunition supplies, though strained by the intensity of fighting and disrupted logistics, never failed completely. American infantry could fire their weapons freely, knowing resupply would come. German forces, conversely, had to conserve ammunition carefully. Many German units, particularly those in the offensive spearheads, ran, critically low on ammunition and fuel, as American resistance stiffened and German supply lines lengthened. A German infantry officer, Lieutenant Hans Schmidt, captured near Bastogne in January 1945, told his interrogators that his company had begun the offensive with 60 rounds per rifleman, a full basic load. By the third day of fighting, His men were down to 20 rounds each. Resupply never came. His company's combat effectiveness degraded rapidly as soldiers conserved ammunition, firing only when absolutely necessary. When American forces counterattacked, his men couldn't generate enough defensive fire to stop the assault. His company was overrun, not because his soldiers lacked courage or skill, but because they lacked ammunition. Schmidt noted, with evident bitterness, that captured American positions contained enormous stocks of abandoned ammunition. American soldiers had apparently withdrawn or been killed, leaving behind cases of .3006, ammunition and M1 Garand clips. His men had tried to use the captured ammunition in their Kar-9 8K rifles, but the American cartridge, though dimensionally similar to the German 7.92 by 57mm Mauser cartridge, was not identical. The American round was slightly different in length and case dimensions. It could not be fired in German rifles without risk of dangerous malfunctions. His men had to leave the abundant American ammunition behind, unusable, while they ran out of their own. The image of German soldiers surrounded by ammunition they couldn't use, carrying rifles that were empty or nearly empty, while facing American soldiers with M1 Garands and seemingly unlimited ammunition, captured the fundamental disparity between the combatants. Germany, for all its tactical skill and soldier quality, couldn't sustain combat against an enemy with overwhelming material superiority. By early 1945, the outcome of the war in Europe was no longer in question. Germany was collapsing under pressure from multiple directions. Soviet forces were driving from the east. American, British, and other Allied forces were driving from the west and south. German industry was shattered by years of strategic bombing. Transportation systems were destroyed. Food supplies were inadequate. Fuel was almost non-existent. The military was disintegrating. In this context, arguments about rifle superiority seem almost trivial. Whether German soldiers carried Kar-9 8K rifles or hypothetical semi-automatic weapons wouldn't have changed the war's outcome. Germany was doomed by strategic overreach, industrial inferiority, and the overwhelming combined strength of its enemies. No infantry weapon could reverse those fundamental realities. But at the tactical level, in individual engagements between small units, the M1 Garand made a significant difference. American soldiers armed with Garands had firepower advantages that translated into winning firefights, taking objectives with fewer casualties and surviving battles they might have lost with inferior weapons. The Garand didn't win the war by itself, but it helped. It helped American soldiers stay alive. It helped them kill enemies more efficiently. It helped them accomplish missions with less risk. For the individual soldier, that made all the difference in the world. After the war ended in Europe in May 1945 and in the Pacific in August 1945, military analysts from multiple nations examined the lessons learned from infantry combat. The superiority of semi-automatic rifles was universally recognized. Nations that had relied on bolt-action rifles during the war began programs to develop or acquire semi-automatic weapons for post-war use. The Soviet Union, which had produced significant numbers of SVT-40 semi-automatic rifles during the war, but continued to rely primarily on Mosin-Nagant bolt-action rifles for most infantry, began developing the SKS carbine as a post-war standard. The United Kingdom, which had used bolt-action Lee-Enfield rifles throughout the war, began evaluating semi-automatic designs and would eventually adopt the FN-FAL. France, with its experience using semi-automatic rifles in limited numbers, committed to developing modern self-loading weapons. The United States continued using the M1 Garand as its standard infantry rifle through the Korean War from 1950 to 1953. American soldiers in Korea, facing Chinese and North Korean forces equipped primarily with bolt-action rifles and some semi-automatic weapons, maintained firepower superiority similar to what they had enjoyed in World War II. The Garand again proved its worth in combat, functioning reliably in Korean winters and generating the sustained fire that characterized American infantry tactics. The rifle was finally replaced in American service in the late 1950s and early 1960s by the M14 rifle, a weapon that was essentially an improved, magazine-fed version of the Garand chambered for the new 7.62 by 51mm NATO cartridge. The M14 retained the Garand's basic operating system and much of its design, testimony to how sound John Garand's original design had been. The M1 Garand's influence extended far beyond American service. The rifle's operating system, particularly its rotating bolt and gas operation, influenced countless subsequent designs. The FN FAL, the G3, the M14, the AR-10, and many other military rifles used operating principles derived from or influenced by Garand's work. The semi-automatic rifle, once considered experimental and impractical for mass issue, became the universal standard for infantry rifles worldwide, a transformation that began with the United States Army's decision in 1936 to adopt Garand's design. For Friedrich Weber, the engineer at Kummersdorf who examined the captured rifle in November 1943, the experience was professionally humbling and personally sobering. He understood weapons design. He understood manufacturing. He understood the enormous challenge of producing complex mechanisms reliably in quantity. The M1 Garand represented an achievement that German industry, at that point in the war, could not replicate. American designers had created it. American factories had built millions of them. American soldiers had carried them into combat across the world. The rifle worked, consistently and reliably, giving American infantry decisive advantages. Weber's detailed report documented all of this clearly. But reports couldn't change industrial realities or reverse strategic decisions made years earlier. Germany would fight the rest of the war with the weapons it had, watching American infantry dominate firefights through superior firepower. The knowledge that the enemy had better rifles was cold comfort to soldiers facing that enemy with inferior weapons. The story of the M1 Garand is ultimately a story about choices and consequences. The United States chose to invest in developing and producing a complex, expensive semi-automatic rifle decades before the war began. That choice required commitment from military leadership who believed the weapon was worth the expense. It required industrial capacity to manufacture precision weapons in enormous quantities. It required ammunition, production infrastructure, capable of supporting high consumption rates. It required logistics systems capable of delivering millions of rounds to soldiers worldwide. Every element of that system had to work for the rifle to fulfill its potential. Germany chose differently, prioritizing other weapon systems, relying on proven bolt-action rifles, and attempting to develop semi-automatic weapons only when the war made them urgently necessary. By then, it was too late. The industrial capacity, the time, and the resources needed to field semi-automatic rifles in meaningful numbers no longer existed. The soldiers on both sides lived with the consequences of those choices. American soldiers fought with weapons that gave them advantages, helping them survive and win. German soldiers fought with weapons that were adequate for the previous war, but insufficient for the one they were actually fighting. The gap between 8 rounds fired quickly and 5 rounds fired slowly, between 3-second reloads and 10-second reloads, between semi-automatic operation and manual bolt manipulation, was the gap between industrial modernity and industrial inadequacy. When those first 50-caliber machine gun bullets punched through Japanese tank armor at Saipan, Marines learned their heavy weapons could defeat light armor. When Friedrich Weber fired that captured M1 Garand at Kummersdorf, he learned that American infantry could fire 8 aimed shots to every 5 German shots. Both revelations illuminated the same fundamental truth about industrial warfare between modern nations. Victory goes to those with better weapons, produced in greater numbers, supported by superior logistics, and employed by trained soldiers who trust their equipment. The United States had built that system. Germany had not. The outcome was determined long before the final shots were fired. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.